A student can use graphs to easily identify the quantity that maximizes profit and the maximum profit the firm can earn. You start by finding the quantity that maximizes profit. The intersection of the demand facing the firm and its marginal cost curve determines the profit maximizing quantity. Let's break this down a little bit and draw a graph. So we'll have, here we're going to measure quantity on this axis and dollars on the vertical axis. And let's just say we've got an average total cost curve looks something like this, ATC. Again, marginal cost must intersect average total cost of the minimum. There's marginal cost. Suppose the market price, and we'll put a number on it to give me, let's say the minimum average total cost is $8. And let's say that the market price is $12. Well, that means the demand facing the firm is a horizontal line at $12. Here's my demand curve facing the firm. To find the profit maximizing quantity, I simply find where the demand curve intersects the marginal cost curve and drop straight down QM. QM is the quantity that maximizes profit. If I'm to the left of QM, an increase in quantity will make profit go up. So if I'm below QM, I want quantity to rise. When I get above QM, an increase in quantity will make profit go down. I know this because when I'm to the left of QM, price is greater than marginal cost. The demand curve is above the marginal cost curve. When I'm to the right of QM, price is less than marginal cost. The demand curve is below the marginal cost curve. So QM maximizes profit. Now the next thing I want to do is to find the maximum profit. The area of a rectangle equals the maximum profit or minimum loss for a perfect competitor. Let's draw our graph again. See what we've got going. Here we got quantity, make it a little bit bigger this time, dollars, average total cost, kind of exaggerate here a little bit, marginal cost. And let's say that the price is up here. Let's say that's $10 right now is the price. So the demand is a horizontal line at $10. And I know that QM is that number right there. The quantity determined by the intersection of marginal cost and the demand curve. All right. I know that profit is total revenue less total cost. I know total revenue is price times quantity. I know total cost is average total cost times quantity. Well, by the distributive law, that tells me that profit also is equal to average total cost. Profit also equals the difference between price and average total cost times quantity. The height to the demand curve is price. The height to the average total cost curve is average total cost. So the difference between those two curves, the difference between these 2 points, the difference between point A and B, is the difference between price and average total cost. Quantity is the distance from the vertical axis to points A and B. I'll do it this way. Here's that's quantity. Quantity is how far I'm moving to the right when I move to point A or to point B. So when I multiply price minus average total cost, I'm multiplying this distance between A and B. And when I multiply quantity, I'm multiplying the distance from the vertical axis to A and B. And if you look at it, I'm multiplying the height of a rectangle times the length of a rectangle. The rectangle is this shaded thing. I'm going to shade it right there. I'll multiply the height of that rectangle times the length of that rectangle. When you multiply height times length, you get the area of a rectangle. Let's look what happens when you have suffer a loss. Suppose we have a situation now where we got, here's quantity, here are dollars, average total cost will be up here, Here's my marginal cost. And let's say here's demand coming out like that. Well, now we still have an intersection between demand and marginal cost. That's still going to be QM. But now when I go up to the average total cost curve, I find that average total cost is higher than price. So here's my price. Here's my average total cost. The difference between those two things, right there, it's the difference between average total cost and price. But now average total cost is higher. Well, that means I'm suffering a loss on each unit that I produce. The cost I'm paying per unit is higher than the price I'm getting per unit, and that distance between points A and B now represents the loss I'm suffering per unit. The horizontal distance still represents the quantity I'm selling. When I multiply the height of that, you see the rectangle again. When I multiply height times base, or height times length, I'm going to get the area of the rectangle. But now that area is the loss the firm suffers. Sometimes the best thing a firm can do is to suffer a loss. We'll talk more about that in the next lesson.